What is bias? By the end of this presentation, you should be able to define bias, be able to describe the differences between the two main types of bias, selection and information bias, appraise how bias affects different types of study. Bias means deviation from the truth, and bias in a study affects the results. Bias is due to the study design or way in which a study is carried out. We cannot measure the extent to which bias influences a study's findings. And bias cannot be corrected for either by increasing the sample size or when we analyse the results. There are many types of bias, but don't worry, you don't need to know the names of them all. They can really be put into two main groups: selection bias and information bias. In addition, confounding is another type of bias which we discuss in another presentation. When we consider our study's results, we should always ask if the observed effect could be due to bias. Selection bias occurs when there is an error in the process of identifying the study population. Selection bias can affect the observed results. For example, in a cross-sectional study, asking for volunteers rather than using a random selection from a population can result in selection bias. It is well known that volunteers are not representative of the population. Incomplete coverage of a population will lead to over or under representation of the eligible participants. For example, let's consider how to estimate the prevalence of childhood blindness in a population. If we only look for blind children in schools for the blind, this will lead to selection bias in many low and middle income countries. In these countries, we will fail to count many blind children as school enrollment is variable or non-compulsory. A good response rate in cross-sectional studies is essential, otherwise the results will not be representative of the population we are studying. It is vital to manage and minimize non-response in a cross-sectional study. We can do this, for example, through repeat visits or by involving community leaders. Case control studies are particularly prone to selection bias. We can minimize bias through careful selection of cases and controls in this kind of study. For example, selecting cataract cases from a private hospital in Dar es Salaam would most certainly result in selection bias compared to Zanzibar, where there is only one referral hospital on the island and it is a public hospital. In a well-conducted randomized controlled trial, selection bias is eliminated by randomization as long as loss to follow-up is minimized and the randomization procedure is carried out properly. Note that if we allocate the treatment or intervention without randomization, this will result in selection bias. An example of this would be allocation to the intervention or control arm by the order in which patients come to the clinic. Information or measurement bias occurs when there is any systematic error or flaw in how we measure information on disease, exposure, or both. This can be due to error by the observer or within the instrument used, and the resulting misclassification can either be random or non-random. Let's show this through two quick examples. The diurnal variation we see in a participant's intraocular pressure can lead to a non-random misclassification, as intraocular pressure always varies in the same direction. Grading cataracts manually can result in random misclassification. These types of measurement bias can be reduced by repeat measurements and calibration of the instruments, use of standardized conditions and grading systems, training of field workers, and use of protocols. Recall bias is a type of information bias and is a particular problem in case control studies. It occurs when participants report or recall an exposure based on their knowledge of their disease status. For example, Smoking is known to be a risk factor for both cataract and age-related macular degeneration. In studies of either of these diseases, cases may either under or over-report their smoking history, the exposure. Underreporting reduces the association of smoking with disease. Over-reporting gives a greater estimate of the association of the exposure with the disease. In conclusion, bias can lead to departure from the truth. That is, the true value of the prevalence or incidence in the population, or the association between a disease and an exposure, or the effect of an intervention. We minimize selection bias in our participant selection through well-devised sampling and management of non-response. We minimize information bias through training and protocols. The degree to which bias influences a study's findings cannot be measured. However, we can reduce the effect of bias by paying close attention to how a study is designed and carried out.